Hello and welcome. Today I want to talk about dot product and normalizing. I have talked about dot product in last lesson. Probably you know the definition of the dot product here. Magnitude of the first vector multiplied by magnitude of second vector and multiplied by cosine angle between them. Probably you have a question about what is dot product usage. Don't worry about that. I will talk about dot product usage and practical usage of dot product in the next section in creating practical shaders. Just follow me and don't worry about anything. Okay, let's talk about dot product and normalizing inside Unreal Engine. What is that? What is normalizing? Normalizing is dividing the vector by its magnitude. The result will be a vector with same direction but magnitude of 1. Let's see this vector. We have R1 green 0 and blue 0. If you remember, the magnitude of vector is a square root of x power of 2 plus y power of 2 and z power of 2. Okay, here red, green and blue. Okay, let's change the R to 2 and let's debug float-free value and see the result. Result is always 2, 0, 0. Okay, the magnitude of this vector is 2 power of 2 plus 0 plus 0 and the magnitude is 2. Let's normalize the vector and see the result. Now we have 1, 0, 0, the same direction but the magnitude of 1. Okay, permit me to talk about dot product. I created two vectors and I want to dot product them, dot them together. Okay, let's change the value to 0, 0, 0 and 0, 0, 0. Okay, the dot product is always completely black. Why? Because the magnitude of them 0 multiplied by 0 multiplied by something, it's 0. Okay, let's change the value to red 1 and red 1 for this, and as always we have white because the magnitude of 1 and the magnitude of 1 multiplied by magnitude of 1 and multiplied by cosine angle between them, it's 0. They are parallel and the result will be completely white. Now if I change the red value to -1, the result will be completely black. Why? The magnitude of 1 and cosine angle between them, that is 180, and the result will be completely -1, completely black, and the result will be -1. If I debug this value, debug float scalar value and connect that to a scalar value, you see the result is -1.00006. Okay, now let's ignore that, it's -1. You see, -1. Okay, let's delete that and let's change the value of the red to 0. The derivative between them is 90, and again we have dot product of black. Okay, let's change the value to -1. Now you know that the dot product result is -1. You want to change the negative value to positive value. For that we using absolute value. Let's take a look at here. We have absolute value symbol here. Absolute value, change the negative value to positive value. And now if I bring the scalar value, debug a scalar, and connect to the dot product, we can see and start previewing, and we can see -1. Now if I connect the absolute value, we can see +1. Very beautiful. Now I connected the ABS absolute value to multiply and a multiplier value, and let's start previewing now. Okay, we multiplied the power of emissiveness to 100. We can bring it down. Also we can use 0.01, sorry, 0.1. okay, it is very good. Now let's talk about the material functions, and let's recreate the normalized node inside the material function. Okay, for creating a new material function, go to your content browser and right click and click on materials and click on material function. What is material function? Material function is it is named, it's a function you want to use repeatedly over and over inside your material editor, and you don't want to recreate the function again inside material editor. You want to have the function as a node. It is refactoring the nodes you want to use over and over again. Okay, let's create a math function and name it to normalize recreation, or let's change it to magnitude creation, vector magnitude. Okay, maybe it's better. Sorry for my magnitude. Okay, let's open it up. We have an output result here. I have created one here. I will talk about that. Okay, we have output result here. Let's bring input. We want to input something to the function and get the output. We want to give input and get output. Because of that, let's bring an input. Okay, the input will be a vector tree. Okay, you can see here, and we want another node brick out float tree component. This node break a vector tree component to RGB. Let's connect that. Now we give a vector tree and we have RGB separated. Let's here with definition of the magnitude of the vector, we have x power of 2, y power of 2, and z power of 2. You can see here. And let's bring the power node. Let's change the exponent value to 2. Its default is 2. Or Ctrl C and Ctrl V, Ctrl C and Ctrl V, and copy. And let's add together them x power of 2 plus y power of 2 and plus z power of 2. Because of definition, you know the definition, I have talked about that in the last lesson. And let's bring add node. Add node again. Let's add the third value to first and second. And now we want to take the square root of this number. For that, search for square root. Okay, and connect that and connect to output result. Okay, very simple. We created this function. Let's save that. Inside here we have a tick. You should check that to expose to search, expose the function to search, expose to library. Let's check that and save again. Now let's use the magnitude function inside material editor. First, bring a vector tree constant value by holding the tree key and clicking change the red value to 2, and let's bring vector magnitude function, connect the vector tree to input of the vector magnitude, and for seeing the result, search for debug scalar value and connect that and start previewing the node. You can see we have 2 magnitude, value of 2 for magnitude, and it is appropriate and proper. Also, you can change the name of input here. You want to vector input inside the material function, and if I save that, you can see we have a vector input name here. Okay, I will talk about the material function a lot inside the course, and let's talk about the last concept. Here it's cross product. Cross product has a little difference with dot product, but there are some differences. The result of dot product is a scalar or float value, but the result of the cross product is the vector tree. Is a vector tree. Sorry. Let's see the cross product visualization inside the browser. You can see we have vector C and vector B, and the red vector is the result of the cross product. The cross product magnitude will be the area of parallelogram spanned by A and B. Okay, very good. It is a little hard, but the usage of the cross product is less than dot product. I want you to know you can search for cross product and see the usage of cross product. The usage of cross product is in a lot of situations, but in creating material editor it has less usage than dot product. Okay, thank you for listening and watching, and I hope you to understand my lesson completely. Don't be scared. I will go through all of this concept in practical, and thank you. Bye.